Today we are working on simplifying radical expressions. This is section 11.2. The first thing we want to look at is the product property of radicals. When we see this property, we see that you can multiply two numbers underneath a radical, take the square root of their product. That is the same thing as taking the square root of each of the numbers and then multiplying those answers together. What we're going to do is be able to break up our square roots into multiple square roots that we can work with. Here I have the square root of 4x. Please notice the square root of 4x can be broken into the square root of 4 and the square root of x. We can see that the square root of 4 is 2. You write that on the outside. If it's a perfect square, you can write down what the number is. The square root of x, though, we don't know what that is, and so we have to write that as just the square root of x. So our answer is going to be 2 times the square root of x. We leave it in what is called radical form. Let's simplify the square root of 48. In order to start simplifying, you want to think about what factors of 48 there are, that one of them is a perfect square. I know that 16 times 3 gives me 48, and I know the square root of 16 is 4, so I can write the 4 down. The square root of 3, we don't know what that is, except it's a non-terminating, non-repeating decimal. We will stop here with our simplifying. We take the square root of any perfect square numbers that we can, and we leave underneath the radical anything that we cannot take the square root of. 4 square root of 3 is the answer. Here we have the square root of 25, x to the 5th. The square root of 25 we know to be 5. We can write that on the outside. Now we need to look at that x to the 5th. If you want to, break that x to the 5th up into x squared times x squared times x to the 1st. You know what x squared, the square root of x squared is. That's going to give us x. And then we have another x squared here. So we'll have the square root of that x squared is also x. The last thing is the square root of x to the 1st power. We cannot take the square root of x to the 1st power, so we'll leave it underneath the radical. And that means that we'll have 5x squared times the square root of x as our final answer. If you see your exponent on your variable and it's an odd number, think of taking that number divided by 2, whatever that answer is. That's what your x to the power is going to be outside of your radical, and then you're going to have an x to the 1st power left over, because with that odd power you're always going to have one variable left underneath the radical. Square root of 7 times the square root of 7 is the square root of 7 times 7 underneath the radical, which we all know to be the square root of 49. And that simplified is 7. So we can kind of shorten this up and say, well, this is the same as 7, the square root of 7 squared, and we all know square root and squaring undo each other, so we're left with 7. Please remember that when you take a square root of a number times the square root of that very same number, you're going to end up with what's underneath the radical without a square root. We'll need that for later in this section. Let's put these together and simplify. We'll have 3 times the square root of 2b to the 4th. So when we multiply the b and the b to the 3rd together. Well, I don't know the square root of 2, but remember what we talked about with that exponent on the variable. Divide it by 2, that gives me b to the 2nd. It's going to be on the outside because we are working with b to the 4th. Take square root of it, b squared times b squared. And underneath the radical is still the 2. We can't take the square root of the 2. It's not a perfect square number. So that is our simplifying of this answer. The next one has 2 times the square root of. Underneath here is 5 times m to the 3rd times n squared. The 5 we cannot do anything with. It stays underneath the radical because we don't know the square root of 5. But the square root of m to the third, divided by 2, that gets you an m to the first power, and that leaves us with 1m underneath. That'd be like m squared times m. Square root of m squared is m. That's written on the outside. And the m that's left over stays under the radical. The square root of n squared is just plain old n, and we still have the 2 that was sitting out front from the original problem. So here is our simplification for this answer. We can take fractions and work with square roots. As long as they're both numbers that we can take the square roots of, life is pretty good. Like in the denominator here, we have the square root of 49 is 7. In the numerator, we don't know the square root of 5. It's okay to have a radical in your numerator. It is not okay to have a radical in your denominator. So if that is a perfect square, please make sure that you take the square root of that number, and then you can write that fraction in lowest terms. Here we have the square root of 11 over the square root of d to the fourth. Let's rewrite that as the 2 radicals. In the top, you have the square root of 11, and that's not a perfect square, so we'll have to leave it underneath the radical. In the denominator, the square root of d to the fourth is d squared. I'm just dividing the exponent by 2 in order to come up with that number. This is our answer. Rationalizing the denominator, that means that we want to eliminate the square root from the denominator. Especially if you have a non-perfect square, this is what we're going to have to do in the denominator. You'll have 7 over the square root of 6. Remember my comment earlier about multiplying a number times itself, and they're both underneath the radical? Well, we're going to multiply by whatever is in the denominator, both in the numerator and denominator. We know that this fraction is really equal to the number 1. So we haven't changed the fraction at all. We're just multiplying by 1. But the deal is we're changing what it looks like. Square root of 6 times the square root of 6 is 6. And on the top we have the 7 times the square root of 6. And this is where we'll stop. As long as there's not a radical in the denominator, we can write our answer. If there is a radical in the denominator, you need to multiply by that radical over itself in order to get rid of the radical in the denominator. Here we have the square root of 5a in the denominator. Let's go ahead and multiply by the square root of 5a over the square root of 5a in both numerator and denominator. On the top, we'll have the square root of 3 times 5a, which is 15a, underneath the radical there. And on the bottom, we'll just have 5 times a, because it's a radical times itself. It's like the number being squared, it undoes the square rooting. I cannot cancel between the a's or between the 15 and the 5 because one's underneath the radical, the other one is not, so this is done. We will be adding and subtracting radicals. When you add and subtract radicals, you have to look at like terms. This term has a square root of 14, and so does this term. So we can add their coefficients together. We cannot add with that the square root of 21. That's a different term. So the 7 square root of 14 minus 4 square root of 14 gives me 3 square root of 14. And then we just add the square root of 21 onto that. If you can simplify 14 underneath the radical or square root of 21, please do so. These are not able to be simplified any further, so our problem is done. 2 square root of 7 plus square root of 28, we can simplify the square root of 28. That's really 4 times 7 underneath the radical, and we know the square root of 4. That's 2. So we have 2 times the square root of 7 plus 2 times the square root of 7, which was over on the other side. When we add those together, they're both like terms. We can add their coefficients. We'll have 4 square root of 7, and that ends up with just one term for our answer. Multiplying radical expressions, we are going to distribute the square root of 3 inside to everything inside the parentheses. That gives us 2 times the square root of 3 plus square root of 3 times the square root of 12, which is the square root of 36. Simplify your radicals if you can. We know the square root of 36 is 6, and so we will have 2 square root of 3 plus 6. Here we are foiling. We have 2 binomials. If we multiply square root of 2 times square root of 2, that gives us 2. Then our outside terms are going to be 2 times negative 3 square root of 5. That gives us a negative 3 square root of 10. That's square root of 2 times square root of 5 gives us the square root of 10. Then our inside terms here are the square root of 5 times the square root of 2, which is also the square root of 10. And our last terms putting together up here is a square root of 5 times a negative 3 square root of 5. That means we will have a negative 3 times. The square root of 5 times the square root of 5 is 5, so we'll have actually a negative 3 times 5. Combine your like terms. The middle 2 terms both have a square root of 10, so we can add their coefficients together. And the 2 and then the negative 15 on the right-hand side we'll put together and have minus 13 as our final answer. We're going to rationalize using conjugates. I want to remind you that if you have an a plus b times an a minus b, you end up with a squared minus b squared, or difference of squares. Please remember that property as we're using it here. If we have a radical in our denominator and there's addition or subtraction going on, we have to multiply by what is called the conjugate. And that is the exact same terms, but the opposite operation has to be done. Notice that the original had a minus sign in the binomial, but what I'm multiplying by on both top and bottom is an addition. So here we will have 2 times 5 plus square root of 3, and in the denominator we'll have these 2 binomials being multiplied together. On the top, 2 times 5 plus the square root of 3. In the denominator, notice it's just an a plus b times a minus b pattern. So we're going to take the first term and square it. We're going to take the second term and square it. So a square root of 3 squared is going to give us minus 3. And as we simplify then, you'll have 2 times 5 plus the square root of 3 all over 22. Please notice I can cancel between my numerator and my denominator. I'll have 11 down here, and that will give us 5 plus the square root of 3 all over 11. And this is in radical form. We don't want to put that into a decimal. Leave it just as it is. Our last problem here has the square root of 5 plus 6 in the denominator. Again, we're going to multiply by the opposite, so we're multiplying by the subtraction. That's that conjugate in the denominator there. And in the numerator, also 6 minus the square root of 5. Let's get our parentheses around there for our multiplication that's going to go on. In the denominator, we will have 6 times 6, which is 36, and then that square root of 5 squared, which is 5. We have to subtract those. In the numerator, we have the square root of 5 times 6 minus the square root of 5. As we start simplifying, we see that in the denominator there's 31. We can't cancel that with that square root of 5 on top, so let's go ahead and distribute that square root of 5 in. That'll give us 6 times the square root of 5 minus square root of 5 times the square root of 5 is 5, and this is all the further that we can go. We have an expression on top and our 31 in our denominator. Be careful with all of your radicals. Leave your answers in radical form. Thank you.